If you are visiting our channel for the first time, please subscribe first to get the latest updates. Today we are going to discuss the concept of the continuity of a function or a continuous function in math. How you will come to know that the function is continuous or not. We will start discussing it through a graph. Then we will move towards the conditions that are basically required for a function to be continuous. So if you are having a graph like this, say for example, this is a graph of any function. Here we have x-axis, here we have y-axis, and this is a graph. Now you have to check what? You have to check, is there any hole or break in this graph to say that whether the function of which this graph is continuous or not. Now it is clear from here that there is no hole or break in the graph of this function. This is basically f of x. This is any function. We are just basically discussing here the concept that how you will come to know that the function is continuous or not if you are given with a graph. Now now it is clear from this graph, there is no hole in the graph of the given function, there is no break in the graph of the given function, and you can draw this graph without lifting the pen from the paper. So you need not to lift the pen, or you need not to lift the pen at a point where this function is not defined. So it is a continuous function. As its name indicates that it is moving on and on continuously without any hole or break. So it can be drawn without lifting pen. So this is how you can identify whether the graph of the given function is a continuous or not. Let's have a few more graphs. Like we have a graph of a function that is like this. Now it is clear from here that there is a hole in this graph. Now what does it mean by the hole? Hole means that the graph of the given function f of x is not defined at this hole or at this point. You can say if it is 1 for some function. So the given function is not defined at x is equals to 1. So there is a hole at that place. It means that when you draw the given function on the graph, you have to lift your pen up in order to avoid that point. Okay, and there is a hole or break in the graph of the given function. So it means that it is not continuous. Okay, so let's have one more example. If you have a graph of the sine function like this, now it is clear that while drawing this graph, I have not lifted my pen at even a single point, because this graph of sine of x is defined at every point and there is no value of x where you can say that it is undefined. So this is also a continuous function. So the functions with no break or hole, or you can draw them without lifting your pen up, are the continuous functions. So this is how you can, this is basically the basic concept of the continuous function. Now let's see what are the conditions that you basically required to check algebraically that whether the given function is continuous or not. So let's write the conditions. Whenever you are given with a function, you need to check these conditions to check whether the function is continuous at a given point or not. So a function f of x is said to be continuous at c. This is at any point, that is value of x, if and only if. Let's see what are the conditions. So condition number 1 is when f of c is defined. It means that if you put the value of c in the given function, then it should be defined at that point of c. Or you can say that, or c should be in domain of f of x. It means c should be in domain of f of x means that the value of c that you put should be in the domain of x, means that it should be included in the value of x that satisfy the given function. So you just need to put the value of c in the given function and check whether it is defined or not. Sometimes it becomes undefined when you came across the 0 in the denominator. So for such cases it is required. Then we move towards the condition number 2. We will also these conditions by applying them on the function in a short while. The condition number 2 is limit of x approaches to c, f of x exists. It means that the limit should exist. Now what does it mean? We have already seen in our previous lecture that when does the limit exist? Limit exists when the left hand side limit is equals to the right hand side limit. Then you can say that, or left hand limit should be equal to right hand limit. Then you can say that limit of x approaches to c exists. For if you still have any confusion, you can refer to the lecture before this on our, I have a video on detailed video on this, that when you will come to know that the limit exists or not. And condition number 3, that is the last condition, is limit of x approaches to c f of x should be equals to f of c. Now this is basically the step that depends on 1 and 2. If the value obtained in the condition 1 and the condition 2 are equal, then the condition 3 will be satisfied. So for a function to be continuous, all these three conditions should be satisfied. So let's have an example so that we can easily apply the rules of to check whether the given function is a continuous or not. So the example number 1 is, you are having a function f of x equals to 2x square plus x minus 5, where you have to check the continuity at c equals to 1. So we will start with the conditions one by one that are required to check whether the given function is continuous or not. So condition number 1 is, we have to find f of c. So it should be defined. So I'll write f of c should be defined. Let's see if it is defined or not in this case. So let's find the f of c as we have f of x equals to 2x square plus x minus 5. And if I put the value of x as c, that is here 1, so I'll write f of 1 is equals to 2 into 1 square plus 1 minus 5. What I will get? 2 plus 1 minus 5, that is 3 minus 5 equals to minus 2. So f of c, that is f of 1, is equals to minus 2. So it means it is defined. So f of c is defined. So we will check the condition number 2 now. We have to find the limit and check whether it exists or not. So limit of x approaches to c of f of x should exist for a function to be continuous. So let's check whether it exists or not. So first we will find limit of x approaches to, as we have c equals to 1, and I'll write the function, first I'll write x approaches to c of f of x. So I'll replace the limit with the of c with the 1, and the function is 2x square plus x minus 5. So we have to apply put the value of 1 in the given function as 2 into 1 plus 1 minus 5, and what we will get? We will get minus 2. It means that the limit exists, as it is not a piecewise defined function. So here we have only one function given, and by putting the value of f of x approaches to 1 into the given function, we get limit of x approaches to c, limit of x approaches to c of the given function. So here limit exists. But if you are given with a piecewise defined function, you can easily check whether you can easily find left and right hand limit by using the different functions that are given. So currently you just need to put the value of x on the given. Now we move towards the condition number 3. This is the last one, and it depends on the condition number 1 and 2. But for these also, according to them, if limit of x, according to this condition, if limit of x approaches to c of f of x, then it should be equal to f of c. Then if it is equal, then you can say that the given function is continuous function. So it is clear here that if we put the value of x approaches to c f of x, that is minus 2, and it is equal to f of c, that is minus 2. So you can say that the given function is a continuous function. So f of x is a continuous function, and if you draw the graph of this function, you can easily see that the graph is having a form where there is no hole and there is no break. So it is a continuous function. Let's have one more example. We will see it quickly. Here we will see the piecewise defined function where f of x is equals to 2x plus 5 if x is less than or equal to 2 and 4x plus 5 if x is greater than 2. Now let's see how you can check all the three conditions on the piecewise defined function. Condition number 1 we will check first, that is you have to find f of c and that should be defined. So I'll find the f of c. Here c is this 2, so I'll put f of 2, and which function I should use from these two? I should use this function as there is equality sign in here where x is less than or equal to 2, while in this function we don't have the equality sign, so the 2 is not equal here. So we will not use this function, we will use the function 1, that is 2x plus 5, and we'll put the value of x as 2 plus 5. We will get 9. Then this is the condition number 1 and it is satisfied as it is because f of c is defined. Then we have condition number 2 where we have to find the left hand and right hand limits. So according to the condition number 2, limit of x approaches to c positive of f of x should be equal to limit of x approaches to c negative of f of x. It means the left hand limit should be equal to the right hand limit. So let's find the left hand and right hand limit and then we will decide whether the limit exists or not. F of x. Now x approaches to c positive means that x is sufficiently close to c but greater than c. So we have to take which function? We have to take this function where x is greater than 2. So I'll write limit of x approaches to 2 positive. The function is 4x plus 5 and I'll put the value of x is 2. 4 into 2 plus 5 and it will be equals to 13. Now we will find the other limit of x approaches to c negative f of x. Now which function I have to take from piecewise defined functions? I have to take the function where x is less than 2. So I'll take 2x plus 5 here. So what it will be then? 2 into 2 plus 5 equals to 9. Now it is clear from here that left hand limit is not equal to right hand limit. So these both are not equal to each other. So I can say that left hand limit is not equal to right hand limit. So we move towards the condition number 3. So for a function to be continuous, all the three conditions should be satisfied. Limit of x approaches to c f of x should be equal to f of c. Now in the step 2, I have forgot to write that it means limit does not exist at x is equal to 2. So we can say that if the limit does not exist in the condition number 2, so it is clear that we cannot say that limit of x approaches to c of f of x is equals to f of c. So a limit of x approaches to c is not equal to f of c. So finally we can say that function f of x is not continuous at x equals to 2. So this is how you can check whether the given function is continuous or not by checking all the three conditions, and if any one of the condition is not satisfied, it means that the function is not continuous. So that's all from today's lecture. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.